Hello everyone, I'm Saketh Saridena. I'm here to present my deep learning and neural networks project today. So my project is an AI-powered student answer evaluation using RAG networks. RAG is basically recurrent attentional graph networks. So as a part of any education and any educational level for let it be undergrad or grad or schooling or high school, whatever it may be. But the evaluation of student answers is a very important step. And it's also been like subjective answers and has long been a laborious and error-prone task. And there are traditional approaches are like plagued by setbacks such as need for substantial manpower and inherent inefficiencies and subjectivity and potential of a lot of human error. And then this project addresses this challenge by proposing an automated system for evaluating subjective answers and leveraging the capabilities of modern technology. So the focal point for this project would be like the to develop a methodology that streamlines the evaluation process, thereby like mitigating the limitations associated with the manual scoring methods. And also, the overarching problem statement revolves around generating answers from reference materials for given questions and subsequently assessing the student responses based on the those generated answers. And by automating this like by automating this evaluation process, we aim to achieve the more objective, consistent, and time-efficient means for scoring the answers. And this is what my introduction for the project is. Coming to the data preparation. So initially, I've taken the ASAC dataset, that is like automated student assessment price dataset, which is available on GitHub. And then like I choose this data set because it has like the student answer and the question and the reference answer. So this was all some other extra things like reference answer and question modifier, reference answer modified. So it's all not required for my project. What I'm making, I just want the question, student answer, and the reference answer. So I've cleaned the data in such a way that it contains three critical components, that is the question and student answers and the textbook answers, that is known as the reference answer in my data set. And the textbook provides like the foundation for generating teacher answers, which are used as benchmarks for the student answers and the evaluation. So the student answers, on the other hand, it reflects the diverse ways in which the learners approach the problem and the questions. So this way, my data set was modified, and then I performed some analysis of the data. Like as you can see, distribution of our answer lengths are almost like most of the times it's more than what the reference answers is, because every student explains the answers in a different way. So the length might vary accordingly. And then I've like after this process, I've process the data, pre-process the data using the embedding generation. Like I've used the sentence transformer models, the EV5, E5 small version 2, to like this model was chosen because its effectiveness in generating high quality embeddings with relatively low computational requirements. So each student answer and the reference answer has been converted into the multidimensional vector by capturing its nonce meaning and relationship to the other answers. So this part has like allowed the project to transition from raw textual data to the format optimized for machine learning and deep learning. So both student and reference answers were converted into the embeddings, and then they were combined. They were combined and concatenated embeddings were created. So this embedding data set is particularly important because it serves as the input for all the project which we are making. And so I've also taken some of the questions and answers from the deep learning question and answers for data scientists. It's a GitHub link which has all the questions and answers for data, deep learning interviews. And from there, I've taken for some of the questions and answers and evaluated it with. I've tested my model on this. So next step is the methods and the models which I used. So I've used multiple models and different methods for applying my data. So as we can see here, I've used a classification neural network. It's basically a small neural network which is designed to categorize student answers into the predefined score levels into three levels. So this approach provides an automated scalable solution to the grading subjective responses. And coming to the this is the architecture of the model and how many hidden layers are there. So output layer is basically a softmax which outputs probabilities for each score category. And regression neural networks, unlike classification, regression neural network is something like predicts continuous scores for student answers, which offers like more of a detailed evaluation of the answer. And the outcome is basically precise and granular scores reflecting the notch quality of the student's responses. So one of the most important networks is the recurrent attentional graph networks, which is which played a significant role in generating teacher answers. It works by like analyzing the question and retrieving relevant content from the textbook and synthesizing a coherent response, like for example, for creating the teacher's answers. The embeddings for this process are generated using the multiple existing models like EV5, small v2, which I've discussed in the data pre-processing stage. And coming to the dynamic weighted scoring, it was used for the evaluation method balances a semantic similarity and critical phase matching to score student answers effectively. So to give the scores for the student answers, it was used, and it works like each sentence in the student answer is compared to the corresponding sentence, and then so it weighs the dynamically. And then coming to the bird score quantifies the similarity between the RAG generated answer, that is the teacher answers, and the ground truth answers of the students. So it provides all the precision recall and F1 scores, which we assess the RAG's performance. So coming to my results. So as you can see here, the implementation of RAG pipeline was a foundational step in automated answer evaluation. And questions were also converted to embeddings, and the closest vector from the database was retrieved as a textbook answer. So these embeddings were generated using two models. One is the E5 small v2 and BG small en 1.5 v, which are chosen for their performance to computation cost ratio. So as my sources were limited and I just used Colab for that, so those models were really important. And as you can see, table one, basically it demonstrates the parameter and the comparison of embedding dimension, sequence length, and time to vectorize the textbook, and time to answer the questions, and cosine similarity. As you can see, I've tested it with two models, E5 and BGE. In all the things, E5 model worked better for retrieving the answers from the questions, and it outperformed by the cosine similarity of 0.92 with the ground truth answers. So I think this is the most like generated by the system are highly accurate and contextually relevant. Coming to the unsupervised question evaluation method, it showed like a strong alignment with human grading patterns. I've used the transformer models for creating chains like the mini LL, LM, L6. It's a paraphrase model. And then I computed the semantic scores based on the cosine similarity. And as you can see, I've processed like 2112 question answer pairs in approximately 158 seconds, averaging like 13.36 seconds per answer. This model achieved like mean absolute error of 0.94 and Pearson correlation coefficient of 0.67. This, as you can see, this figure shows the distribution of predicted scores across the different questions. And this uh, figure 4 highlights the overall score distribution and demonstrating the system's ability to like replicate human like grading patterns. And coming to the supervised question answer evaluation, this model also delivered like wonderful results. It utilized concatenated embeddings for student and answers, like teacher and answers as input features. And this classification achieved like 93% accuracy. Meanwhile, the regression model excelled in the mean squared error of 0.06. So on the whole, I would say the results demonstrate the effectiveness of the combined approaches. Like the crack pipeline exhibited robust performance in generating accurate teacher answers with E5 model, achieving high cosine similarity scores. And the unsupervised evaluation method provided a scalable human-like scoring capabilities, evidenced by the alignment of predicted scores with ground truth distributions. And supervised models added precision, with regression model delivering the most accurate results for the score prediction. So it's all the combination of all three, RAG and unsupervised learning methods and supervised learning methods. So I want to conclude this project by just showing you the conclusion. And I would say, in conclusion, this project basically demonstrates the how artificial intelligence can transform the grading process in education, and the results shows how the models excels at generating accurate teacher answers by which align closely with the human grading patterns. And also, looking ahead, I think further improvements could include like expanding the data set to cover wider range of questions, and refining the scoring models for better generalization, and incorporating the feedback from multiple educators and across the world. And this by integrating also feedback from the teachers and students, this would be the future work of this project. And I have included the GitHub repo and code, which has all my code and data, and it has all the description of the workflow and evaluation results and etc. Thank you so much. This is my project description.